We have a GitHub repository that shows a visualization of this solution, right? And it's under github.com tech puzzles matrix 01. So we're going to run this little visualization and discuss it. Press enter. So I'm going to zoom in on this, and this is our input matrix. And you can see it has a 0 up in the top left and all ones. Now what we expect is trails coming out from the 0, and we should see that in our first pass, the pass from the top to the bottom, from the top left to the bottom right, should be setting things, where if the 0 was in the bottom corner, then it would do it on the second pass, which is the pass from the bottom to the top. So let's see what happens. And I think I can... And this is going to cause problems. And now I just want to show that the first step is to set the matrix to all the ones to the maximum value, and we just picked obviously the length cannot be 7 because a corner to 1, 2, 3, 4, 5 is really the maximum, but for some reason we set it to 7, which is obviously higher than the maximum. And now we're going to calculate the real values using a 2-pass system, which should be n squared as opposed to n squared times n squared, which would be really bad. So that would be brute force. This is dynamic programming. So let's see if we can press enter here. And here we go. It's going to start iterating right now. And you can see the red is showing you your current position, and it's also looking up. So it's looking up and to the right. And you can see what happens is when it finds a difference, when the current position is the look back position, whether it's up or down or left or right, is less, strictly less, then it copies the value from the strictly less to the current position plus 1, right? So it's building these trails. And you can see that it completed the matrix, and it's going now to look back, and it's not going to find anything because in this particular case, the 0 was only in one position, and it was up in the top left corner, so it finished it on the first pass. Now this press enter. So that did one input. Let's do another one. And I apologize for the screen moving, but this is kind of cool. We'll make it into a web app someday. There ought to be a way to... So now this is the new input. It's in the lower corner. You see it? So the 0 is now in the lower corner. It's already set the maximums. So let me press enter. It's comical. This just makes it easier to see it. And here we go. It's going through and it's doing the exact same thing, but on the first pass down from the top to the bottom, it's not going to find anything. They just stay as 7s. And again, the yellow is the look back, the red is the current position. But now it's going back, it's going to go backwards, and it's going to start setting the trails. These are extreme cases where the 0 is in a corner, but there could be multiple zeros, and that case is coming up. And there's also another case where zeros could be anywhere. That's coming up too. But, start with simple cases in order to make sense out of it, right? So that's the best approach. You can see there's also a shading to the colors of the numbers, of the distances. And if you see, there's grayish, and then it's shades of gray. So the darker, one is darker, and it can show the trail. So here's the input. That was finished, right? So now here is input, another one with 3 zeros, right? And you could slow this video down to whatever speed you want. And now we're going to do this one too, right? It's going to, let's just do this, press enter, and do this. And so here we're seeing what the matrix looks like before we start solving it, right? We set all the values to 10 this time because it's a 5 by 5. That is more than what the maximum value could be. And then we're going to try to solve it. And then we're going to just let the student test this themselves. So here we go. We'll zoom in on this. And the solution is happening now. And for some reason, it's not going. Not sure why. And let's do this. And it's continuing to solve right here. See, it looks back, and then it's setting, because it found some zeros, it's making a trail. And you'll see that up in the top, it tells you what it's doing. It's doing an update in a position, it's looking left, it's looking up, it's doing an update. Whenever it finds strictly lower, it copies that value from the look back +1 to its current position, and now it's going backwards. It's going from the bottom to the top. And it's correcting any issues that were there. And we'll let it finish, and then we'll hope this helps someone out there who's trying to visualize what this matrix 01 actually does. And it's much more efficient than brute force, because brute force can be, in that example, 10 to the 4th versus 10 to the 8th, which makes a big difference. So I'll let it finish. You can see that at the end, and please test this on all cases, because you can see there was another correction right there. It found that there was a 2 and a 3 next to each other, but a 2 and a 4. All the values have to be difference by 1 or 0. They can't have gaps of 2, right? According to the specification. And if there's a neighbor that's 1 and a neighbor that's 4, that doesn't make sense. So there we go. We're done. Thank you. Peace out to everybody. You want to say peace out? Peace out.